in terms of speed of molecules. Okay, let's get into this one. So we have this is x-axis, this y-axis, let this be z-axis. So let there be a molecule moving with a speed v. So that there's a one wall, there's another wall. Let me, so what is the speed of molecule? It is moving in a space, no? So it will have x component, y component, and z component of velocity also. Postulates I would have just read, but because our conceptual questions are based on the postulates, therefore I gave help of diagram. Any conceptual question, take help of this postulates or the assumption what we made. Okay, these are the walls. So what is the area of cross section of wall? So side length, let it be L. So what is the speed of molecule? So what is this M? M is a molecule. Like this, many will be there. It'll be moving in a space. So what is V is equal to? V square equal to Vx square plus Vy square plus Vz square. As it is moving in a space, we know vector. This one. Okay, let's get into the derivation part here. So let's consider the x component of velocity of the molecule. So if there's a wall, what are some assumptions here? Let m be the mass of the molecule. In corner, let me write mass of molecule. M naught, molecular mass, capital M. This M naught, capital M will be mass of gas. Small n, number of moles. Avogadro number. K, Boltzmann constant. R, universal gas constant. Getting this one? So these are some formulas, how they are related. So these are the symbols which I'll be using very often. One more N, no? N is number of molecules. So mass of gas, I can write it as mass of each molecule into number of molecules. Mass of gas, I can also write number of moles into molecular mass. Molecular mass, I can write it as mass of each molecule into Avogadro number. And R is equal to KNA. These are some from your chemistry, what I just brought these ideas. Capital M is mass of gas. Mass of gas in terms of mass of molecule or molecular mass you can express. Okay, let's get into the derivation part. What we are going to derive? So how the pressure of gas I want to express in terms of speed of molecule. So here there's a wall. The molecule will go and collide as it is elastic collision. So what is the change in momentum of this? Change in momentum of molecule. Delta P should be equal to mvx minus of mvx. So this should be 2 mvx. Fine. So what is the distance it will cover? L. What is the time taken for two successive collisions with respect to a wall? Means the molecule will start here at t equals 0. Then again to come and collide with this wall, what is the distance it will move? L and L. So time interval between two successive collisions. Shall I write delta t? So what is the distance it will cover? Say, I think it's very simple. The molecule will collide. Again, when it come and collide, so for that weapon, it will move with a speed Vx. It will collide here. Again, it will cover a distance L. No? So what is the total distance covered? L and L. With what speed? With a speed Vx. So therefore, this will be delta t is equal to 2L by Px. So what is that delta t? So this one. Now, what is the force exerted? Force exerted by molecule on the wall. Delta F should be equal to change in momentum by time interval. So change in momentum So this is due to x component of velocity, no? Okay, this is due to one molecule. So due to several molecules, what we can write? This is due to one molecule. So change in momentum per second due to all molecules colliding the wall or the wall. So what shall we write? Shall we add up this one? So change in, or so like a force will write here. Huh? Force exerted by all molecules that are moving towards wall 1 are that are moving towards wall 1R. So there should be Fx summation of delta F. So this should be equal to how much here, no? Okay, there's a force here. So let's calculate the pressure. So we know force. So how you can calculate? Pressure equal to force by area of wall. So force is what? Fx. What is the area of wall? L square. So this should become M. So this is due to X component. Like that open, there'll be force exerted, and what is L cube? L cube will become volume. So put it here. Okay, we'll derive further. There's the volume of gas. I think capital V is small v. So let me write it as, uh, I think it is understood, no? Capital V is the volume of gas. So this should be equal to, this I'll call pressure. Similarly, Py, what you can write? M into V summation of By square due to Z component of velocity, Vz square. So what is Vs? Strictly volume, not speed of something. Volume of container or volume of gas, whatever be that one. So total pressure, therefore the pressure equal to Px plus Py plus Pz. Okay, no. So this is the speed. So according to Maxwell's equation, so what we can write is this should be the speed of a particle. From the beginning only I wrote it. So this will become, and what is the total pressure? Okay, I'll bring it later on. Okay, there's a thing, you know. So we know, as we know, pressure is a scalar or a vector. Anybody? Fluid statics, go back. Pressure scalar or a vector?
Vector, sir.
Pressure vector, I will break your head.
No, sir.
If you say vector, then definitely what happen? If you were in class, no, I would have beat you. Definitely. Scalar, no, pressure. So therefore, pressure along X, pressure along Y, pressure along Z, there's nothing called like, no. So what is the total pressure? Will be same P only. Pressure is a scalar. So as we know, pressure is a scalar. Therefore, Px equal to Py, Pz equal to P. There's a reason. So therefore, now I'll write it as P plus P is equal to mv summation of, so this will become 3p. This will be, or one next step, I'll introduce this one. Okay, p is equal to 3p, let it be mv. So this is what v square, you can write it. Summation of v square. So 3p equal to m by v summation of v square. Then what is this summation of v square? What is v square should be equal to? V square summation of v square in general, we can write it as v1 square, v2 square, v3 square, so on by n. Can you remember this? This the average like this we can introduce here, v1 square, v3 square. So this particular quantity, how to, what is summation of v square? Anybody wants to interpret?
Sir, mean of velocity square.
Mean of velocity squares, it should be like it also v1 square plus v2 square plus v3 square. So this quantity is what I should write it as vrms. So what is this? This is equal to summation of v square by n. I think mathematical symbols, summation of v square means what you can write it as, okay? v1 square plus v2 square plus v3 square plus v4 square. So here we'll introduce quantity called okay, root mean square speed difference, which is equal to v1 square plus v2 square, v3 square, so on. Okay, or if you want, you write one more. Yeah. So this will become summation of v square. Summation of v square, what you can write? N vrms square. Okay, this will become n into. Now, what do you mean by n? Number of molecules it is. So therefore, the final expression will be 1 by 3 mn. What is use of this? We are trying to relate this particular speed, like a pressure of a gas in terms of speed of molecule. That's what I brought. See, V is the volume of a gas. There'll be a constant, no? What is small m mass of molecule? What is n number of molecules here? So therefore, final the equation will be P is equal to, there's a very famous equation which students should remember. Mn by 3V Vrms square. Now, what is Mn? Shall we go for further expansion? What is Mn? So we had a formula. Can you remember? What is small m into n will become mass of gas? Shall I write capital M? So there's a thing. There is a Maxwell's equation. So the summation of speed, like this, the speed of molecule. No, initially I brought it. No? Again, in the Maxwell's, I'll introduce later on. Vx equal to vy square plus vz square like that. Later on, will Maxwell's law of equipartition of energy, there will write it. No, now may not be needed. You'll get confused. Okay, no. This is it. So we know this. Can we also write m by 3v? So what is the density of gas mass by volume? So rho by 3. Okay, this is the expression for root mean square speed. So what is VRMS we should call? Okay, further this root mean square can I rewrite in any other form? I want in terms of molecular mass and temperature. So we know ideal gas equation. I think all of you know ideal gas equation. PV equal to nRT. Here only PV equal to nRT. So I'll let me write here. Let me introduce all this one. So this volume of gas. Yeah. PV equal to nRT. So therefore PV equal to what we know, small mn by 3 VRMS square. So shall I write nRT? Okay, let's try to bring molecular mass. Small n by molecular mass, from where you can bring it. Capital M by n, or small n, can we write it as any of the symbols? Huh? We can use this one. I'll make it small. Yeah, look at that one here. Number of moles. So can we write it as capital M by m naught? Okay, small m into capital N, what you can write it as? Small m into capital N. Capital M. So capital M get cancelled. So what is VRMS? 3RT by m naught. The same equation, because the temperature here we have brought in terms of pressure. Or what is m naught? Or can you bring in terms of mass of molecule? So this R, can I replace? R, can I write K into Na? I'll do one thing. I'll further go for it. So R is equal to what we can write? Kna. No. Na by m naught, what you can write it as? 1 by m. Okay, like this, what happened? The RMS speed of a molecule, we are expressing in this particular way. And now, very first question student will ask is, so what is RMS speed? Anybody? Because you know in chemistry. Tell me what is the RMS speed?
Sir, root mean square.
Okay, fine. Any other answer? Chemistry completed? All of you? Gaseous state over? Hey, please reply no. S no,
Yes,
nothing.
sir.
No. So somebody reply what is there? Okay, gaseous state completed. Okay, now tell me what is the RMS velocity? What do you mean by this? So somebody replied it's a root mean square velocity. So what is VRMS? V1 under root of V1 square plus V2 square plus V3 square and so on Vn square by N. Okay, fine. Some of you have taken JEE Advanced coaching also from 8th standard. Sir, what is there? I will take the square of root mean square, no? I'll square all the speeds. I'll take mean of that. Then I'll take under root. Okay, VRMS. Anybody, any student can tell, no? Because here we are squaring, then we are taking mean, then we are taking root. That's why root mean square speed of molecule. Okay, that you are looking at the equation you are telling, but what is the meaning of that? Why we should square and take mean? Why can't only mean? Like that, if you go for no, the average velocity, we have average velocities. After this, we do have average velocity also. Now, what is average velocity? The average velocity of molecules will be, this should be equal to 2 kT 8 pi. Okay, sorry, this one 8. And the average speed of molecules. Next, most probable speed. So this is equal to how much it is? 2p by rho. There are molecules which are they moving with a speed more than VRMS, less than VRMS, equal to VRMS in a container. All speed, all molecules will not have speed. Different molecules, they'll move with a different speed in different direction. That's what the postulate we have put. So there are some molecules in a container which will have a speed equal to VRMS, less than VRMS, greater than VRMS. But what is VRMS? Why VR? Sir, velocity may be positive or negative, so we take square of velocity. Ah, what is this? How you are giving reason? Somebody is telling, sir, velocity can be positive, negative. If you take the average of that, you'll cancel out. That's why to eliminate that negative sign, we are squaring it. I think is a stupid reason, I can say. Anybody still? Since chapter got over, that's why I'm asking question. If we were not over, no, then definitely I would have gave suitable explanation. And now we have to ask question, sir, with what speed actually molecules are moving? Will they move with this speed or this speed or this speed? They move with a random speed, because what is the postulate says? Molecules move in all possible direction with all possible speeds. Is it okay? Are they move with VRMS speed? No. So what is the speed? Speed of molecules. Next again, speed of molecules lies between 0 and infinity. So different molecules, they're moving with a different speed. So then what is VRMS and most probable, what is the average speed? I think we have to ask ourselves this question. Yeah. Anybody wants to answer? Oh, it's just a statistical process. Huh? No, 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 no. Chapter got over and we should know the significance of it, no? Chapter got over and we should know the significance of it. What is VRMS? We should have thought, no? Without that thinking, what is VRMS? Then, okay, everyone knows formula. 3 kT by small m or 3 RT by m naught or select a 3P by rho. Okay, what is the purpose of this discussion? So we are able to express now the temperature of gas in terms of RMS speed. Are you able to understand now? So what is our main purpose? I want to measure pressure and temperature of gas. If I know RMS speed of molecule, yes, I can measure that, I can predict the temperature. If I know RMS speed of molecule, I'll get the pressure. Similarly, if I know average or most probable, yes, I'm able to express. So what is our main discussion? We want to express the pressure, temperature, and energy of a gas in terms of the speed of molecules. But since the different molecules are moving with a different speed, then which molecule you'll take reference? So for that purpose, we have brought VRMS. But still, what is VRMS? There's no answer. Am I get? All of you getting know what is the discussion? 1 hour we discussed. What is the conclusion of this? What is our purpose? We wanted to express the pressure, temperature, and the energy of a gas in terms of speed of molecule. Since the different molecules, they're having different speed, which molecule I should take reference? Can I ask, suppose the molecules are moving, can we stop this molecule and measure speed? Not possible, no, we can't do that. Can we take this one molecule in reference? Okay, this molecule is moving, we'll measure its speed. Okay, then we'll express the pressure of gas in terms of speed of that molecule. Not possible, we cannot take a molecule as observation. These are the problems what we are going to face. So therefore I brought VRMS. So what is VRMS? We don't know. But we are able to express pressure, temperature. So what is VRMS? Okay, some mathematics. I'll take, I'll square, then I'll take mean, then I'll take under root. Okay, there's a, you can say it's a language. It's a, you're just interpreting that particular symbols. Square, mean, root. That's all, no? Square, squaring, then taking mean, then you're taking on. That's why I'm calling root mean square speed. This is not explanation. Huh? Somebody is telling positive, negative. So if I don't take the mean of this, if I don't take square, then what happens? Plus minus will cancel out. Root mean square speed, not average velocity, average speed of molecule. Okay, here we are taking average. No, what is V average? V1, V2, V3, Vn by n. That's what average speed. No, I think it's a very serious issue. Means we do learn, but the significance, all those things we do miss. So what actually we are gathering information. We are not analyzing anything. So what has become science now? The science is what now? Gathering information, not science. It'll become history, historical science. It has become history, that one. So what is the science now? Nowadays, science is what, like gathering, like it's similar to history. What history will do? Historical people, what they do, they just gather the information. No, that's what historical science is. What it's happening. Okay, I'll give time. So tomorrow we have 1 day time. Please do think what is the significance of this. What do you mean by that? See, don't give definition. Already definition is over. There's a definition, so don't bother it. What is the significance of this? So why you are writing it? Say this is what your question. Your question should be from where you brought this. Are you getting the idea? So I'll round it off. From where, why? Why we should write VRMS like this only? Why not V1 cube, V2 cube, V3 cube, Vn cube, and let this be V cube by n? So why not root? Let it be cube root. That's all. No, what's wrong in asking questions of like that? Do think, okay, tomorrow I'll continue because this is very important. If I don't ask this question and if I just write this and I'll go that one, it's a history class, it's not a science class. That much I can say. You whether you learn in chemistry, when you learn in physics, or in whichever subject you learn, this is the core idea of the KTG or gaseous state. Okay, now we'll wind up the class and tomorrow we'll continue from here.